let's just move on further towards our new concept, which is all about the equations of line which is parallel to the x-axis and y-axis. But before going towards this particular topic, let me ask you a little question, that do you know where the points 2, 0, minus 3, 0, 4, 0, either 5, 0, so goes on, n, 0, where n is any real number lie in the Cartesian plane? Do you know where all these points lie in the Cartesian plane? Yes, we already are aware about such kind of the coordinates, that they always lie on the x-axis. They always lie on the x-axis. Why so? So let's just see. First of all, as we are saying about, or we are talking about the x-axis, on the x-axis the y coordinates are always 0. We know about this fact that on the x-axis the y coordinates are always 0. So let us suppose if we are talking about this horizontal axis, this is our x-axis, which we always represent by x dash. On this particular x-axis, always remember y is always 0, and hence the coordinates will be of the form minus 2, 0, 1, 0, 3, 0, 4, 0, and so goes on. So that is why we are saying that on the x-axis the y coordinates are always 0. It means that there are some facts which are related with it. Very first is every point on the x-axis is of the form x, 0. You can relate it from the previous slide, that the points 1, 0, 2, 0, 3, 0, so goes on, n, 0, where n being any real is actually lying on the x-axis, because every point on the x-axis is of the form x, 0. Further, we can say that the equation of x-axis is nothing but y is equal to 0. The equation for the x-axis is nothing but y is equal to 0. So this is really an important point. The second point is really very important. The equation of x-axis is y is equal to 0, because we do know that on the x-axis y coordinates are always 0. So it means that the value of y is nothing but is equal to 0. So y is equal to 0 is called as nothing but the equation of x-axis. So always remember, on the x-axis, the y coordinates are always 0, and equation of the x-axis, that is x dash, is actually nothing but y is equal to 0. So these are some of the facts that are related with the x-axis. Now let's just talk about, in the same manner or in the similar manner, let's just talk about the y-axis. So next, if we are talking about the y-axis, so y-axis is definitely nothing but this vertical line which is actually represented by y dash, and further on the y-axis, always remember the x coordinates are 0. On the y-axis, always remember the x coordinates are 0. That is why the points or the coordinates are always represented as 0, y. They are always represented as 0, y. So if I'm saying the point 0, 1, 0, minus 1, 0, 2, 0, 3, where they all are lying, so they are definitely lying on the y-axis, because the x coordinates are 0 on the y-axis. So there are some other facts which are related with this particular concept. So first of all, the fact number 1 is every point on y-axis is of the form 0, y. As we can see over here, every point on the y-axis is of the form 0, y. Always remember x is nothing but 0. X is nothing but 0 on the y-axis. So the equation for the y-axis would be x is equal to 0. The equation for the y-axis is x is equal to 0, because the x coordinate on the y-axis is 0. So its equation would be of the form x is equal to 0. So always remember these two facts which is related with the y-axis, and the two facts which is related with the x-axis, that the points on the x-axis is always of the form x, 0. The points on the y-axis is of the form 0, y. The equation of the x-axis is y is equal to 0. The equation of y-axis is nothing but x is equal to 0. 0. Now these facts will help us to find out the equation or to draw the graph of the equation of the lines which is nothing but parallel to the x-axis and parallel to the y-axis. Now let's just move on further. Let's just talk about x is equal to 2. Let us suppose we have x is equal to 2, and we do know that we can also represent x as equal to 2 into the formation of linear equation in two variables. How come? Because we do know that a linear equation in two variable is represented as ax plus by plus c is equal to 0, and if there is an inavailability of y variable, then we can write this equation as x plus 0 into y minus of 2 is equal to 0. We can write such an equation, that is x is equal to 2, into this formation, x plus 0 into y minus of 2, which is equal to 0. As you can see, if I'll take transpose 2 towards the other side, so it would be minus of 2, and if I'm taking 0 into y means again 0, so 0 plus x is again x, so this equation would be of this form again. So always remember, for any x is equal to 2, we can represent it in this particular formation. Now there is some fact which is related with this x is equal to 2, with this x is equal to 2. So what is that? Let us suppose I'm talking about the note 1. Always remember, the graph of x is equal to a. The graph of x is equal to a. Of this form, basically, x is equal to a, x is equal to a being 2 over here. The graph of x is equal to a is a straight line which is always parallel to the y-axis, which is always parallel to the y-axis. We will definitely see how we are concluding this first point over here with an example, but before that, always remember or take a note that the graph of x is equal to a is always a straight line which is parallel to the y-axis. The graph of x is equal to a is a straight line which is parallel to the y-axis. Similarly, if I'm talking about the variable y is equal to a type, if I'm talking about the graph of y is equal to a type, let us suppose I'm taking y is equal to 2. So if we have y is equal to 2 graph or y is equal to a, again it is a straight line, but it is parallel to the x-axis. It is parallel to the x-axis. So always remember, the graph of x is equal to a is always parallel to the y-axis, and the graph of y is equal to a is a straight line which is always parallel to the x-axis. Let's just see how we are concluding or how we are talking about these 2 points. So let us suppose if I'm drawing the graph of x is equal to 2. Let us suppose I'm starting with x is equal to 2. So remember, x is equal to 2 makes a straight line which comes to be parallel to the y-axis. According to this note, it comes out to be is equal to parallel to the y-axis. So let's just see how it is coming out to be equal to, it is coming out to be a straight line which is parallel to the y-axis. So let's just draw the graph of x is equal to 2. So first of all, as we know that we have x is equal to 2, it means there is no y in the equation. So for any value of y, the x will always remain same, that is 2. So let us suppose I am taking this particular graph and the Cartesian plane over here. So if x is equal to 2, if x is equal to 2, it means we can take the value of y as anything. So let us suppose if I am taking the very first point as x as 2 and y as 0, because there is an inavailability of y, so we can take any value of y over here. So if x is 2, y is 0. This is my first point that I am taking for the equation x is equal to 2. Now let's just move on further. If I am taking y as 1, I can take y as minus 1, I can take y as 2, I can take y as 3, y as 4, y as minus 1, minus 2, minus 3, minus 4. I can take y as any value, because we do know that as in the equation x is equal to 2, we do not have y. So it doesn't matter at all, because the value of x will always remains the same. So let us suppose I'm taking some of the points over here. Let us suppose I'm taking y as 1, x as 2. Again, I'm taking the point as y being 2, x as 2, and further I'm taking y as 3. Y as 3, the point will remains the same. And further, if I'm taking a and b, or I can take any value as x has 2 being y as -1. If I'm taking any such values and I will join all these lines or these points, all together, I will get a straight line which is actually perpendicular to the x-axis, but most importantly, it is actually coming out to be parallel to the y-axis. As you can see over here, this is coming out to be parallel to the y-axis. So it means that the graph of x is equal to 2 is actually a straight line which is coming out to be parallel to the y-axis. It is actually coming out to be is equal to the y-axis. So it means that for any x is equal to a, it always comes out to be a straight line which is perpendicular to the x-axis and parallel to the y-axis. So always remember, the graph of x is equal to a. In general, the graph of x is equal to a will always be a straight line which comes out to be parallel to the y-axis. And in the same manner, if we are talking about y is equal to a, if we are talking about y is equal to a, where y being any value, let us suppose if we are talking about y being 3. So if I'm taking y as 3, so let us suppose if I'm taking y as 3 over here, so this is y as 3. So we can take any value of x over here. We can take x as 2, we can take x as 3, 4, 5, 6, -1, -2, -3. For all the values of x, the value of y will remain the same. It means that it will comes out again to be a straight line. It comes out again to be a straight line which is of this form, and thus again we can say that this is nothing but a line which is perpendicular to the y-axis, but it is coming out to be parallel to the x-axis. It is coming out to be parallel to the x-axis. So hence, y is equal to a is the equation of the line which is actually parallel to the x-axis. It is coming out to be parallel to the x-axis. So this is parallel to y-axis. This is parallel to y-axis, and this is parallel, or this equation is parallel to x-axis. So this is all about the equations that are parallel to the x-axis and to the y-axis. Now let's just move on further and let's just see the example number 1 related with the concept of equation of lines parallel to the x-axis and parallel to the y-axis. So it says solve the equation 2x plus 1 is equal to x minus 3 and represent the solutions on the number line and the Cartesian plane. So let's just start solving this particular equation first. So first of all, we have the equation as nothing but 2x plus 1 is equal to x minus 3. So let's just solve this equation. First of all, we will take all the variables towards the one side, the constants towards the other side. So first of all, I'm taking x toward this side, so it would be 2x minus of x plus of 1 is equal to minus of 3. So 2x minus x is nothing but x. So this is nothing but x plus 1 is equal to minus of 3. At the end, transpose plus 1 toward the other side, we will get x as minus 3 minus 1, which is nothing but minus of 4. So at the end, we are getting x as nothing but is equal to minus of 4. So this equation is actually of the type x is equal to a, where a being a negative number, that is minus of 4, where a being a negative number has nothing but minus of 4. So if we have x is equal to a, then the line that will be formed on the graph will actually comes out to be parallel to the y-axis, because we do know that for x is equal to a, it comes out to be a straight line which will be parallel to the y-axis. But it says first of all we have to represent it on the number line. So let us suppose if we are taking this number line, so this is my x, this is my x dash. Let us suppose I'll write it over here. This is my x, this is my x dash, this is my x dash. So we have to plot the point x as minus 4. So first of all, as we can see over here, this is nothing but the point x as minus of 4. So this is my point that is actually representing x is equal to minus 4. So this is the representation of x is equal to minus 4 equation on the number line. So this is all about our first part. Let's just move on further towards the second part, or the representation of the solution x is equal to minus 4 on the Cartesian plane. So as we have the equation of the solution as nothing but x is equal to minus of 4, so we do know that for any value of y, x remains the same as minus 4. So either we can take the value of y as 0, the x remains the same as minus 4. We can take the value of y as 1, y as 2, y as 3. We can take any value of y. Always x remains the same. The x will remains the same as nothing but is equal to minus of 4. So we can take the coordinates as minus 4 comma 0, we can take minus 4 comma 1, minus 4 comma 2 and minus 4 comma 3 and so goes on. So let us suppose if I am taking the xy plane over here, so x is minus 4, so we can see this is nothing but the point that is actually representing x as nothing but minus of 4. So this is the point which is actually representing x as minus of 4. So let us suppose if I'm talking about minus 4 comma 0, if I'm talking about minus 4 comma 2, if I'm talking about any particular point which is actually lying on this line AB, which is actually lying on this line AB, is all representing those points that are satisfying x is equal to minus of 4, because if you can take any value that is lying on this line AB, they all will represent x is equal to minus of 4. So this is nothing but a line which is actually coming out to be parallel to the y-axis. This is nothing but coming out to be parallel to the y-axis. So this is all about the geometrical representation of x is equal to minus 4 on the Cartesian plane.